Our next speaker is Dr. Nathan Phillips. Dr. Phillips is a professor at Boston University, and he writes, I'm a physiological ecologist who studies land climate interactions in terrestrial ecosystems and human-dominated environments, including exchanges of energy, water, and greenhouse gases, including methane and carbon dioxide exchanged between the air and leaves, soil, buildings, humans, and pipelines. I work with advocates, community members, and policymakers to apply my research to advance sustainable communities and a habitable planet. Please welcome Dr. Phillips.
Thank you, Debbie, and thank you, League of Women Voters. All right, let's jump right in. So here's my outline, and I like to borrow it from my colleague at Lund University, Kim Nicholas, who put this outline out at the first Science March. And so for this Gas Leaks 101, climate change across the fracking process chain, very similar. It's leaking or venting, as my friend Texas Sharon Wilson points out, that it's not always leaks. A lot of this stuff is intentional venting, and it's warming. It is us, and it's happening from wellhead all the way to burner tip. We're sure about it. It's bad, and we can fix it. So next slide, please. So in 2013, I'm going to start down where I really know what's going on at the burner tip, closer to that end of the pipeline. This is Boston, and here are 3,356 leaks that we documented in 2013. Subsequent to that work, a study just published last month, led by Harvard University, showed that across the downstream sector, about 2.5% of the gas is leaking into the atmosphere from pipelines. And that accounts to about a little under 10% of our entire greenhouse gas emissions inventory from all sectors. Now, that's just the downstream sector. If you add going up the sector all the way to the wellhead, one of our best estimates would be that from Ramon Alvarez in 2018, and those folks published an estimate about 2.3% leakage rate from everything upstream of this downstream distribution. So you put those numbers together, and that's almost 5% leaking gas, and that makes the leak rate for gas from fracking down to the burner tip quite a bit worse than coal for the climate. Next slide. And we know this is not just a Boston thing. Next slide. This is the paper that we published. We found lots of leaks, over 6,000 leaks in Washington, D.C. Next slide. In Manhattan, in Cincinnati, all across Durham, North Carolina. This problem is across the eastern seaboard and also in other parts of the United States. Next slide. And we know why. It's not any kind of mystery. We have very, very old infrastructure. And down here where I do my work, these are the old pipelines. And if you look a little closely at some of these, you can see type that shows that some of these are 8-inch cast iron low pressure from, I'm seeing 1860, and another one from 1882. We have old infrastructure. And when I look at people like, again, Texas Sharon Wilson and the work she does with Earthworks to use video cameras, that we see that the leaks occur across the process chain all the way up to the well pad and everywhere in between. So we know why it's leaking. We know where it's leaking. It is a bit of a mystery because this is an invisible gas. And so it can leak so many different places. We're likely missing a lot of places, but everywhere we look, we find leaks. Next slide. And we know that we're a big part of this. Methane comes from a lot of different areas. There's biogenic methane from wetlands and rice paddies and landfills, but the fossil fuel production from oil, from gas, from coal is a big part of it. And we can use, as previous speakers pointed to, we can use things like isotopic tracers or other hydrocarbon tracers to fingerprint the fossil fuel component of this. And this study from 2018 by Warner et al. Is one of those that showed us that of all the methane that's coming up, the lion's share, 17 out of 25 teragrams or trillion grams of methane into the atmosphere, is attributable to the fossil fuel, natural gas and oil and coal. Next slide. And this is consistent with the inventories that we do. So this is the very latest inventory from the IPCC, Intergovernmental Panel on Climate Change 2021. And that reddish arrow going upwards to the left, that thickest one, that's the fossil fuel component. So according to the IPCC, fossil fuels are the largest emitter of methane, anthropogenic emitter into the atmosphere. Next slide. And coming down to the national level, our most recent 2019 methane emissions, and I believe this is a lowball estimate, but you can see there, if you add the natural gas and petroleum systems, about 30%, add coal mining to that, 7%, fossil fuels are the largest emitter of methane into the atmosphere in the US. Next slide. So it's bad when it's a bit difficult to run around and try to find all of these places where it's leaking out. But when we get up into the atmosphere and we measure the net result, we can do that quite well. And so NOAA tracks this every month, every day. And what we see is it's bad because you can see it's accelerating. That curve is going up and up. So we have a very, very big global problem. The contributor of methane to overall climate change is about 10%. And growing. So it's a big problem. It's a climate emergency. Next slide. It's bad, but how bad is it? And here I want to bring it back to, this conference is about health impacts, and I don't want to let that aspect go because there are a lot of problems. There are explosion problems with leaking gas. It kills trees in the downstream sector. It costs ratepayers money, but also a big one, and climate is the health impacts. And we saw things like what happened out in Los Angeles area in 2015 with a gusher of a leak over there at Porter Ranch, people getting nosebleeds, people having real serious reactions to it. And, so we do have these problems even in our homes where we have leaking gas, or even out on the streets when we have leaks like this, or even smaller leaks. Next slide. So that one was a very particularly big leak, but I want to make a point here. We actually went out to the neighborhoods and measured the gas as it flowed down off of that Porter Ranch, Aliso Canyon gas leak into the neighborhoods. And we were getting spikes of methane at about 60 parts per million in the air. And so it's not just the methane, it's all of the other stuff that's being carried in that gas stream that is really bad. Volatile organic compounds like benzene, toluene, xylene, and other things that are bad for respiratory health, bad for neurological health, cancer agents for which there are no lower safe limits. And so we would see levels of methane at 60 parts per million. That's about 30 times or more greater than the background value that would be there if there were no leak. Next slide. And so that was making folks sick there at that level. And the California Department of Human Health and Hazards, I'm forgetting the exact name there, pointed to the fact that the gas and the odorant in the gas was causing these health problems. I've highlighted that text down there toward the bottom. Next slide. And I just want to bring this back to areas around where we live here. This is Somerville, which is close into Boston. And we measure values as bad as what was found in Porter Ranch, up to 90 parts per million. I think this graph is showing a peak of. So if people are getting sick out in Porter Ranch at 60 ppm of methane and all of the other stuff in it, we're actually breathing this stuff when we walk our kids to school every day as we go by these gas leaks. Next slide. And here's, an example. I used to walk our kids to school every day down the street, and we would walk right by a gas leak. Here, I can't even see my own slides, what the percent of gas is in the soil there with that combustible gas indicator, but certainly we would smell this every single day going by there. Next slide. 37%, I guess. Okay, so let's get to some solutions. We can actually fix this problem. So work done in 2016 by a graduate student, now Dr. Margaret Hendrick in the Boston area, found that of the leaks here in the downstream sector, half of them, or only 7% of those leaks account for 50% of the leaked gas. We call these super emitters. And, this is fracked gas, even though it's downstream here. But we also know from other work that these super emitters occur all across the gas process chain, all the way up from the well pad on down to gathering lines, compressor stations, that there are a few leaks that account for the vast majority of the leaks. So if we can find and fix those leaks, we have a good shot at really, having a cost-effective way to address and triage this problem. Next slide. But really, we have to think about what that is in service of, because there's two ways to think about this. We can triage this system and patch these leaks to afford ourselves the resources and the time to transition to inherently cleaner and safer and healthier energy systems for heating and for electricity. Okay. And that's what we need to do. We do not need, and it's not good for us to think about fixing these leaks to double down on the energy system of basically last century. So with that, I'll just go to my last slide and thank all of the groups that worked with us. There's Margaret Hendrick, there's Bob Ackley, who I first learned about this gas leaks problem from, and then all the other advocates and some funding agencies who have supported our work. So thank you so much.